So far, all the programs we've seen were actually quite simple. You could look at their code and figure out that the whole program was progressing very linearly through the set of statements given. So those are called straight line programs. If you want, you're given a set of instructions or statements, and in a straight line programs, these are all executed one after the other, very linearly. In a branching program, by opposition, you have a bunch of lines of code, and the way a branching program will work is that some instructions will get executed, but then at some point precisely an instruction is hit that will say, hey, jump somewhere else in the code and go on from there. So some other set of instructions is executed, and then at some point it stops, and then it jumps yet again and starts executing here. Now, another way of representing the same thing is that you have a set of instructions, and then at this stage you have two options: either go this way or go that way, and go on with executing those instructions. So you have to have this test here that will decide which way to go. Should I go left or should I go right? Because if you don't have the test, then it's just a matter of reorganizing the code, and it would just be a linear flow again. So the test is very important. It gives a dynamic decision to the program on where to go next. So instead of doing all those squiggles and everything, in the future, I'll represent blocks of code with just blocks. So I would have a block here, I would have a block there, a block there, and the tests will be represented by diamonds. So here, what I have is that I have a block of code, then I hit a diamond, and I can go for one or two possibilities, so either left or right, depending on the result of the test that is here. And after that, other things are possible. So let's see how Python does that. So Python has the if-else construction that implements the test. So the idea is that you start from some block of code, and then at some point you hit a test. And this is signified in Python by if, and then you write the test, and then you have a colon. And there are two options. Either the test succeeds and you execute the block that follows, or the test fails and then you execute the block that's indicated after the else. And after either way, after either of the two possibilities, so this is true or false for the test, then you go back to executing the same code again. Okay, so this is the graphical picture of what happens, and the way it's represented in the source code is that you have if the test and then a colon, and then you have some block of code. So if I write A for block A, B, C, D, and this is test, then I can have block A. So block A is here, and it starts, it's aligned with the if here. And then block B, which is executed if the test is true, is indented a bit by the same amount everywhere. And then back to the original indentation, there is an else. And then another block is indented with C. And then finally, back to the original indentation, there's block D. So this is how you signify in the source code this whole picture of what should happen. So you have indentation of blocks that the indentation helps delimitate the blocks that are represented here with boxes. Okay, so this is a simple if-else in Python. Now, what if you want to do something more complicated? So maybe what you want to do is you can want to start from a block of code, do a test, and then if the test succeeds, you do something. And if the test fails, then you do another test. And only if the test fails, you do this other test. And then depending on the result, you either execute one block or the other, or actually you maybe don't want a block, you want another test again, and again two options, and finally, if all the tests fail, you end up here. And this is all afterwards followed by another block of code, and then it goes on. Okay, so maybe I label these things A, B, C, D, E, and F, and those are tests, so T1, T2, T3. So this is the general picture of what you want, and of course the arrows go from the top to the bottom, and each time the success of the test is indicated on the left, the failure on the right. Now, how do you write that in Python? Well, you have to have an if, and then, you have to start with A, the code A, and then you write a first if, which corresponds to test 1. And then you put some indentation, some additional indentation, and this additional indentation gives you code block B. And if that fails, then you want to do another, you want to do an else, but you want on top of it to do another test. So what you use in that case is elif. And elif is followed by a second test, test 2. And if that test succeeds, then you will execute code C. And if that test fails, then you want to do yet another test. So this would be test 3. And if that final test 3 succeeds, then you execute code D. Otherwise, you execute code E. And after all these tests, you do code F. Okay, so this is how you would do it. And note that this guy here is optional always. And also something very important is that the code here, for instance, is only reached if the second test is true, but also the first test is false. So what I mean is C is not executed if B is. Similarly, D is not executed if either B or C is. And E is not executed if B, C, or D are executed. There's only one way out if you want. And it can be like this, like that, or like that. And on top of it, the tests which might have side effects are only tested if the previous tests fail. So if any of the tests succeed, then the rest is just cut off and ignored, or at least until that part. Okay, so this was how to do a basic conditional, what a basic conditional is and how to do a basic one in Python. And we'll see now actual examples.